What's up, guys? Welcome back to another video. So guys, in this video we're going to be looking at graphing rational functions, and I want to pull up Desmos here because we're going to be using this a little bit in this lesson. But let's take a look at graphing rational functions. So we're just going to jump down, and you can see from the graphs of these functions that we're going to have two asymptotes. And remember, asymptotes are those lines that the graphs will approach but never actually get to. So, for our graphs, for our rational functions, we're going to have two asymptotes for those functions. All right, let's take a look at this. So we're going to compare two graphs. And I want y'all to see the difference between 4 over x and then the graph of 1 over x. So let's pull this up in Desmos and take a look at it. So we'll type in our first one, which is 4 over x. And then we also want to type in 1 over x. Okay, so 1 over x is in blue here. And then 4 over x is in red. And so what is the difference of those two? What's the difference in those two? And you can see that the red one, which is 4 over x, is a little bit more like pulled outward away from the origin, or away from this midpoint. And then the 1 over x goes in closer. So when you kind of multiply or have a number in your numerator, that's going to pull, the bigger the number, it's going to pull that line kind of farther and farther out away from the origin. And then the smaller that number on top, or the bigger the number in the denominator, it's going to pull it in closer towards the origin. All right. So now let's look at some translations. So if we add or subtract a number directly to the x down here in the denominator, that's going to shift the whole thing to the left or right. And then if we add or subtract a number here on the end, that's going to move the whole kind of thing up or down. So you're kind of side to side, and your up and down shifts. All right, let's graph this function here, and then we want to take a look at domain and range. So let's type this in: -4 divided by x plus 2 minus 1. All right, and then let's look at domain and range. So you can see that the function goes up forever and it goes down forever, but there's one little line in here where whatever this asymptote is, there's this area in here where it actually doesn't touch. It approaches it, but it never actually gets there. And that's, I don't know if you can see this, but that is this line right here, right at 1, or -1. So we could write our range as, it's greater than this -1 and it's less than -1, but it's actually not equal to -1. So we could write the range as y is not equal to -1. Y is not equal to -1. Now let's look at the domain of that function, and we'll see something similar. It goes to the right forever, and it goes to the left forever. But this line right here, it never actually approaches, or it approaches, but it never actually gets to. And that line is, it looks like -2. So for our domain, x cannot be equal to, x is not equal to -2. Okay? So for your domain and range for these functions, usually you're just going to have one point on your x and y that the function is not equal to. All right, let's go down here and take a look at this. So this is a similar rational function, and let's type this in and kind of do the same thing here. So we have 2x plus 1 divided by, and actually we want to divide this whole thing, so let's put this in parentheses, divided by x minus 3. All right, and we're going to get kind of the same thing where, let's see what line it's approaching. And it may be hard to see. I think that it may be more difficult to find what line that is. What the asymptote is. But what we can do is we know that x can't be 3 because we can't divide by 0. So we know we know 3 is going to be the asymptote here. So x equals 3. We know x can't equal 3. And then for the range, trying to think how we could identify that point. Let's see if 1.7 over here and 2.2 over here. Really, I guess what we could do is find what we could do is we could move this over. Actually, that may change it. 2.2, 1.7. I'm thinking it's just going to be this line right here, right at 2. So I think 2 just may be our asymptote. So we'll say y not equal to 2 is our range for this function. All right. Now, for this last part, rewriting and graphing a rational function. So if they tell you to rewrite a function like this in this form, this is how you can do this. You're going to have to do some long division here. So 3x plus 5, and we are dividing by x plus 1. X plus 1. So what times x gives me 3x? And we know that's a 3. So 3 times x is 3x. 3 times 1 is 3. And then we can subtract these two. 5 minus 3 is a 2. And there's nothing else to bring down, so this is our remainder. And remember how we write our remainder. So our answer here is going to be 3 plus 2 over x plus 1. Okay? 2 over x plus 1. And then this, actually, we want the plus 3 or the plus k to be over on that side. So we'll move plus 3 over here and erase this one. So here we go. We have it in the correct form now. So when you do that division, it gets it in this form. And then we can graph the function and describe the graph as a transformation. So, and you can graph it using Desmos, but if we just look at the transformations here, we have this 2 up here. So when we have a 2 in the numerator up there, I think that this would be a stretch. By a factor of 2. We're also moving up 3 because we have a plus 3 on the end. So we're going up 3. And then we also are moving left 1 because we have a plus 1 right in there next to the x. So we have a left 1. All right, so stretch 2, up 3, and left 1. All right, guys, so that's just kind of some of the ideas with graphing these rational functions. If you have any questions, feel free to leave a comment or send me a message, and I'll get back with you. But thanks, guys, for watching. Hope this makes sense. I hope it helps, and I'll see you next time.